Hi, and welcome to the Bread and Butter podcast. This is a developer podcast. We basically pair two related projects together and have them solve problems in real time, like bread, like butter. And today we're discussing the topic of Web3 privacy, but how these two particular projects solve privacy in their own way on the EVM networks out there, like BNB. Also joining us is going to be Julian he's an expert and he is a moderator for today's discussion. He'll continue the conversation much later in the episode, as you'll see. So Nick and Josh from Oasis and Aztec, they're going to be answering questions such as why privacy solutions or confidential computation is needed now in Web3, and how are their particular projects going to uniquely solve for the lack of privacy. They also touch base a lot on a lot of new use cases, and it's just great. They also discuss their interest in BNB, specifically with the Binance Smart Chain, and Greenfield. It's going to be cool. So we asked Josh a couple of really important questions that I think everyone needs to know, such as what do developers need to know before they start using Aztec and Noir to begin with? Like, how are they going to be using some of the primitives, and really how does it work and in relation to the BNB ecosystem? So you'll get some alpha in that way. And he also discussed the compatibility that Aztec Connect has and can have with the BNB Chain, which is great. And then we have Nick from Oasis Network, who does an awesome job at explaining exactly how BNB developers can expect to use TEE. So the topic today is ZKP and TEE. What is it? So this whole episode did a lot of really unique insights, and I'd love for you to stay tuned. It's a fascinating discussion, and lots of topics are brought up, and I think we'll learn a lot about Web3 privacy and how it's going to affect the BNB ecosystem and beyond. So let's get right into it. Joining us today is Josh from Aztec. He is part of developer relations, and Nick Hynes. He is currently leading tech at Oasis Network. So obviously, the Binance Smart Chain and the BNB Chain is a public blockchain network, and Oasis and Aztec both have their own solutions for like privacy. One is ZKP and the other is TEE, and I really wanted to figure out and break this down with both of you. And we'd like to differentiate the two in order for BNB developers to know what exactly to expect in the future to really empower the BNB chain ecosystem with privacy and any confidential computation capabilities. So Josh, can you explain to us what is your role in Aztec and what do you do?
Yeah, so I lead the developer relations team. We're focused on getting our products and the tools we're building in the hands of developers to help build privacy-preserving applications, Ethereum related. So our main products right now are Aztec Connect, which is a zero-knowledge role on Ethereum that has privacy enabled by default. It's really the only privacy scaling solution on Ethereum today. But we also have Noir, which is a zero-knowledge proof programming language, and it's general purpose, so it's not exclusively used in blockchain contexts. You could build like a Web2 application that leverages zero-knowledge proofs and write your proofs in Noir. It is used frequently in blockchain contexts, and like we're designing it as a smart contract language for our future network versions of our network. So developers will write privacy-preserving applications in Noir. Like you could write a zero-knowledge proof in Noir, compile it, and get like a verification contract in Solidity, and you could deploy that to any EVM. So you can like start using it in any like blockchain context that uses the EVM like pretty easy. So yeah, just like helping educate developers but that is how it works, how they can start using it to build stuff.
Rad. Okay, cool. That was a really good explanation. And Nick, just again, just same question. What do you do? What is Oasis all about? And what's your role? And what are you guys looking to do?
Thanks. So yeah, as mentioned, I'm Nick. I'm the tech lead at Oasis Labs, and I've been building the Oasis privacy layer, pronounced OPAL. And that's a streamlined cross-platform privacy workflow that allows devs to build and add any kind of privacy to their new or existing dApps running on any BNB chain, just like BNB. And they can use standard tools like Solidity, MetaMask, Hardhat, without ever leaving their environment. In fact, users, they don't even know that they're using OPAL. It's completely transparent to them. So you get privacy and scalability with all of the user experience and developer tooling that you love from Ethereum.
Awesome. Okay. So you guys tackle the same thing from two different approaches, and I'm going to just go back and forth with some mutual questions that either of you can answer. So Aztec first. So Josh, I'll leave this question to you. What is the flexibility of a smart contract with Aztec? What can it do now?
Yeah, so right now, our network, Aztec Connect, is just a private payments L2. So within the Aztec L2, we can just send notes to each other. We can send transactions to each other that are completely confidential, meaning the sender's hidden, like the sender's encrypted, the recipient's encrypted, the amount, the assets. All you can see on the public explorer is like someone did something. This is pretty limiting. Like it's like reminiscent of Bitcoin, where all it does is just like you send value back and forth to other people. But this way it's completely private. So I guess it's more like Zcash.
Oh, solid. So quick question. So does it hide the sending account address as well, or is it specifically just the amount and the asset types?
It hides the sender and the receiver. So pretty much everything about the transaction. The cool thing with Aztec Connect is you can leverage the EVM on Ethereum L1 for programmability. So we've called Aztec Connect the VPN for Ethereum in the past, and that's the idea that an Aztec account can initiate a transaction. Like I think our most popular contract right now is a bridge between the Aztec network and Curve, and users are swapping ETH for staked ETH from their Aztec account. So they're basically, instead of holding ETH on Aztec, you're wrap staked yield. But it's completely anonymous on the L1 who's doing what. So if you're interacting with L1 from Aztec, you can't have privacy of like transaction data or the protocol that's being interacted with, because Ethereum is inherently transparent. Like we can't change that. But you get anonymity when you interact with contracts on L1. So if you look at the block explorer on Ethereum, all you'll see is someone from Aztec is doing a trade with Curve, or we're like working on an NFT bridge right now. Someone from Aztec is purchasing an NFT or creating an auction for an NFT, but we don't know who it is. So like everybody, like people are hiding in the crowd of Aztec users. So all you know is like someone who has used like deposit doing. So we say transactions with L1 are anonymous, but like transactions within the L2 are completely confidential. So if you want programmability with Aztec, you have to route to L1. This is kind of limiting because like there's only a limited amount of user input you can pass to L1 through zero knowledge proofs, because like generating zero knowledge proofs is really computationally expensive and they're expensive to verify Ethereum. So get like the full range of composability Ethereum. It's like integration with the OpenSea NFT marketplace would be pretty difficult to do.
I see.
Because it just requires a lot of input data.
Okay.
But things like with DEXs and like our NFT integration that we're working on is with Zora, because they're actually like pretty simple protocol, because all their contracts are on chain. Like there's no off-chain data.
Nice.
Yeah, that's where we're at with like programmability within Aztec today. You kind of just like route to Ethereum L1 we get some scalability when like if users that are doing simulation are doing at the same time, we can batch those transactions together and those users will split the transaction costs. So like if 5 of us want to swap ETH for wrap staked ETH around the same time, there'll just be one transaction posted to Ethereum. That's the aggregate of all our trades. And then it will just like, the rollup will distribute the funds accordingly after it gets wrap staked ETH back. So then we would split the transaction cost 5 ways. So we do have some scaling benefits of like aggregating transactions this way, but like the main benefit you get by using Aztec is privacy. Like we're not competing with other L2s or other chains on transaction costs. We're competing in this like fundamentally different value proposition that's private.
Right. Yeah. I see that is really, really clear while reading your documentation. And so to my understanding, you already have a working semantic with Curve, and you're essentially providing the anonymity on your layer 2 with complete confidentiality for the amounts, the sending and the receiving address, and the type of token that is being sent. And you can do this with various wrapped tokens that are compatible with the layer 1 blockchain that you are plugged into. So to my understanding, for now you are capable with the Ethereum blockchain, which is fantastic, which means that you would even share the same compatibility with the Binance Smart Chain, which in my overall question to you, just a yes or a no, is the end all be all result trying to be compatible with multiple EVM blockchains? Is that the ultimate goal for Aztec?
Yes. Ultimately, we will have essentially light client verifiers on every EVM and non-EVM. So any smart contract chain will be able to verify like proof of correctness of deposits and withdrawals. So then people could deposit assets into Aztec or withdraw them to any chain we're integrated with. And you could also use Aztec as like a privacy preserving bridge. So if you wanted to send assets from ETH to Binance, you could just do it through Aztec. This is part of like our next major upgrade that we're doing. But Aztec 3 is going to be much more feature. Actually have private L2 itself, we'll have private state as well as public state, and then this routing to layer 1 for like additional composability as well. So it's going to be like much more featureful. Well, essentially, we will have programmability on our L2 itself, but like that's still a ways away.
Fantastic. Yeah. Thank you for explaining that, going all the way down the rabbit hole. We're going to go a little bit further down the rabbit hole with you again, but I want to give a chance to Oasis and for Nick to really explain his side of it as well. Nick, and really kind of explain to us what is exactly the flexibility that an EVM smart contract would have in relation to Oasis.
I actually have a quick question for Josh first. So I would like the part about the scalability benefits you get. How does that work though? Do you like use like a recursive ZK proof, or do you like have like the sequencer batch them up? Like how does that actually work?
Yep. Yeah. So we have recursive proofs. So we get privacy because users are generating zero knowledge proofs on their computers wherever they're doing it. So they're hiding information there. The thing is, when we're interacting with layer 1, there's certain information that public, like which smart contracts on L1 are being interacted with, which assets are being sent, how much those assets are sent. So that's actually public information. So let's say I want to do that ETH to wrap staked ETH swap. I'm going to create a proof on my machine that basically proves to the protocol that I have the amount of assets and everything. Then I'm going to like say, oh, I want to do this swap. I'm going to send it to this Curve bridge. I'm going to send this much. And we have a sequencer service. So like I'm going to send that proof and those details to the sequencer. And then let's say you're doing the same thing for a different amount. You'll also send that information to the sequencer. The sequencer is going to say, oh, I have these 2 similar transactions. They're going to the same place. They are using the same assets. The amounts are different. I'm going to like keep tabs on those assets. And then our sequencer is doing, like, it's actually aggregating a whole bunch of proofs. So it's like these L1 interactions, it's other just L2 to L2 transactions, it's all the types of transactions that are in reports. It's rolling those up into a mega proof. Like those mega proofs can hold up to 896 transactions. And then that mega proof is actually what's verified on a. So the sequencer sends that mega proof to Ethereum to be verified in a Solidity smart contract. And then it posts all the necessary data to like recreate those transactions and call data, like for data availability purposes. And then, yeah, that's like executes the state transition to the next block.
Cool, thanks. That makes sense. All right, so it sounds like the sequencer, if you wanted to run your own sequencer for privacy, I guess you could do that, but you would lose out on the scalability benefits, or you could like run over an anonymizing network or something like that. But okay, cool. Thanks for explaining. That was I read the docs, but I didn't quite understand how that part fit in, wasn't in there. Okay, cool. Anyway, we're on to Oasis. All right, so Oasis is a little different. So the idea of Oasis is to have a completely and perfectly compatible EVM smart contract environment where you can have as much privacy as you want. It's just code. So like, let's say I wanted to build an NFT with some private data, and I will have the NFT on Ethereum. Let's say I have Azuki, because Azuki is like a sick NFT. So I want to add some private unlockable to that. And then you might already be familiar with unlockables on like networks like Rarible, like submarine on IPFS, but those aren't really private. They're private to everyone else but the platform operator. But you can use Oasis to create a private NFT by simply bridging the NFT, not the NFT itself, but like bridging the ownership of the NFT over through Opal to the Oasis Sapphire network, which is our confidential EVM, and then having the encryption key be released to you from the Opal side smart contract. And like you can do this within like an NFT marketplace where you don't even need to know that Sapphire or Opal or Oasis anything exists. So like you just click the button, like you have sign a transaction, which will do the bridging for you, but you don't have to think about that. And then you get the key, download the private data, decrypt it on your local machine, and then you unlock it back from the bridge, and it goes back over. So that's just one example of what you can do with the very modular and configurable Oasis privacy layer, since it's, again, just code. I mean, other things you can do are like games. I'm a big fan of games. So like imagine you have private state in games, and like we're just going to keep it above board here and say it's like Fog04, right? So in many, I mean, like very popular peer-to-peer games, you have like Fog04, like everyone likes League of Legends, right? But like the map is hidden and you can't see where your enemies are. And now you can't really do this on public networks because they simply lack privacy. But you could instead have some of the gameplay be moved over through the Oasis privacy layer onto this private EVM and do some of the game computation there, like attacks, critical hits, fog of war computation. And then once that game state has been updated, send it back over to the L1 for processing, like distributing NFTs, rewards, loot, and so forth. But the point is that you can create whatever you want. Like I can't sit here and enumerate all the possibilities because they're really just endless. Who would have expected, for instance, that you could use Solidity to code up like Uniswap v3? Like that's some really quality engineering. So the idea is that Oasis privacy layer allows you to bring your own creativity and your own tools and experience to the table to build any application that you think needs privacy. So in the same way that a trusted execution environment works for just like regular just machines on your desk, Oasis privacy layer is like a trusted execution environment for your smart contracts.
It's a trusted execution environment. Okay, so and then so my question to you, because I think the key difference here would be, will then like an Ethereum token, let's just take the Ethereum token in and of itself. Like, can you explain to us then, how does the Ethereum token, even if it's a wrapped Ethereum token, how does it then get executed within this private trusted environment? Is the token on the Sapphire trusted environment? Is that what it's called? It's called the trusted environment and it's called Sapphire?
Yeah, just called Oasis Sapphire, but it like implements a trusted execution environment, or TEE. It's actually based on hardware TEs, but we can hear. So the token, it's like, so you know JavaScript, right? Like when you're messing with JavaScript, it's in like this like sandbox, and like you can interact with the world by like pulling on these little levers like object and like network and fetch. It's like that for Opal, right? So you don't have the token, but you have a handle to the token. You can't operate in the token directly, and that's ideal, right? Because you don't want to be moving these assets over. Like bridges are, regrettably not perfectly safe. So you want to minimize the moving of assets, and you want to operate on them. So what you do is you send this handle or proof over to Opal, and then you operate on the Oasis Sapphire using the handle. So you say, oh, this person owns like this many tokens. I'm going to do some complex operation on them, like not a swap, because swaps are like very simple, but like maybe doing some like some derivatives and like time-based things, and then with using like proprietary algorithm, I don't know. But then it sends the result back over to the L1. So you never really have the token on Sapphire, but you can operate on it as though it's there.
I see. And it sends the results back to the original network. Where is the statement of anonymity then being posted? How does one prove that I'm on Ethereum or I'm on BNB and I used TEE to then execute a private, I don't know, a private transfer? Does that end up on this TEE? Where exactly is it then posted?
Yeah, the proof is protocol based, right? So you have the Oasis network. So Oasis network is a L1 that provides confidentiality features using hardware trusted execution environment, so Intel SGX. And then you can use, that whole network in the protocol does mutual attestation, so every node in the network can determine that every other node in the network is a trusted execution environment, essentially. And then they all do consensus. So you send the data over for execution and processing on Oasis Sapphire. That's happening with a trusted execution environment. And the security of the protocol is what gives you the trust that your confidential execution is happening with, well, privacy and also integrity. And then, of course, it's bridged back over using the integrity of the bridge so that you have an end-to-end private, well, end-to-end high integrity, and then for the parts that are happening within Oasis Sapphire, also privacy.
So with trusted execution environments, you're inherently trusting that execution environment to be secure and do the computation properly. And with zero knowledge proofs, we're essentially trusting them. And like, I guess there's also trusting the implementation of the software to do it properly. I'm not super well versed in how trusted execution work and how data is passed between like requesters and executors. But with Aztec, you're not sending your data anywhere, like you're just doing it on your machine.
So Nick, can you explain to us like what sort of problem is Oasis trying to then solve for the lack of privacy in Web3?
For sure. Right. So Oasis is trying to solve for just overall lack of privacy. I mean, we're specifically excited about things like data management and on-chain secret management for off-chain data and like distributed computation using like new trust execution environments for machine learning accelerators. So that's something that we're really going for. But in the meantime, we're trying to patch up all of the places that are leaky and could be improved by like just general purpose privacy. So it's not just swaps, not just DeFi, but like secret ballots for DAOs, games with private states with randomness that you need trustworthy, and even like AI. Once we're going to get there, like we have actually several customers building right now using our on-chain data management offering, and it's basically allows you to do end-to-end confidential machine learning, which is really useful for things like genetics, healthcare, and actually private market analysis. So like basically like pricing for private assets. So yeah, we're really just trying to go for all this big general thing, big ideas, and it's all going to need privacy.
Beautiful. And Josh, same question. I'll throw it over to you.
Yeah, I'd say, I mean, a lot of the use cases are similar. A lot of the most, like the biggest traction we're seeing is just with like the simple use cases, like payments, just like having private payments, bringing privacy to that domain is like super useful. Like we have like private payments. We have multi-sig wallets on Aztec today. Yeah, are you guys familiar with Constitution DAO? Like they raised $48 million last year.
Yeah.
2021. But like a big problem with doing public fundraisers like that is the other parties participating in the auction knew exactly how much we had all bid on the Constitution. So it made it difficult to win. But there was a Constitution DAO 2 bid earlier this year, and there was actually a multi-sig deployed on Aztec, and people could donate to the multi-sig on Aztec privately. So we could do like private fundraisers essentially. This is super cool. And it was managed by a multi-sig on Aztec. It's like building on the payments use case, but in more advanced use cases, specifically in the blockchain context, that become really useful and just like extend the capabilities of new types of organizations we're seeing emerge on blockchains today. So
I would imagine various social goods that are capable now in both of your guys' solutions. And so the problems with public networks you see don't offer this right now, obviously, right? So what do you guys, and Josh, I'll start with you first. What do you see that public networks get right? And really briefly, what do you think their current limitations are? Specifically, how do you believe that your team, Aztec, solves the issue that you care to really acknowledge? And if you want to kind of specify this with, why is it important in terms of like the user's owned data? What is the current limitation that you see that you're getting right and solving for public networks?
Yeah, I think public blockchains do a lot of things very well. The biggest thing is like just permissionless access. Anybody can access these things as long as they have an internet connection. That's huge and revolutionary. They're like censorship resistant, so people barred from the system because some organization or leader says so. So that allows for like much stronger guarantees about security and just like accessibility. So those are super huge. Also is like self-sovereignty, like people being able to own their assets. Like not only are they able to access them whenever they want, they can also take full responsibility of that ownership. Like being able to own your asset, like own your digital assets and take full responsibility is huge. The only like correlate in real life is basically owning things in physical space, like having physical goods. Because everything else in our digital lives are basically you're entrusting like other people to own them for you and then give you access to them when you want. That's like your email or your bank assets or whatever it is. So that's huge.
So far what I have is you have self-sovereignty, you have self-ownership, and you have privacy. Is really kind of, I like the way that you put it. It's like privacy is almost like table salt, and it's a necessity. And
it's table stakes. Table stakes. Like when you bid, like you need privacy just to play the game in enterprise. So table, but like that would be funny.
We'll keep that. Okay, I like it. So table stake. Okay.
And then just one more piece is the permissionless access is really self-sovereignty isn't useful if someone can censor you from the network. And
Nick, what's your perspective?
Yeah. So, I agree with Josh completely in that public networks are really great public goods. And I like them because they have amazing security and decentralization. You can't really beat the huge number of validators that Ethereum has. And then while you're there, you get deep liquidity and just all the users. And that's really the reason why we're both here, right? We're adding a layer to these public networks because they're great. They just need a little bit of privacy. And it's honestly almost surprising how they got so popular while just having everyone's data out in the public. Like, even for people who have nothing to hide or they're not doing anything wrong, it's still weird to be able to track you across dApps. And like Web2, that would be almost unthinkable. Like, people are up in arms about Google tracking them, and that's even with their consent, and they're getting stuff for free. Unlike Ethereum, it's like MEV and people who want to dox you and steal your stuff. So it's like, imagine like if you walked into a voting booth and someone was like looking over your shoulder the entire time to see how you vote. Like in the political climate, if you're like in the US right now, like maybe you're gonna get shot or something. Like that's not great. So, and like the same kinds of things apply to these public networks. When you have, for instance, like someone voting, like an early vote could sway the rest of the votes, or it could open them up to retaliation later. So the idea of having this DAO and being able to control the assets with decentralization is fantastic. Just that it's not great if you don't have the ability to keep things private when you need to. And that's where Ether technology comes in, and like that's where the Oasis privacy layer comes in, where you can add confidentiality, just the right amount of confidentiality and privacy to your app without impacting user workflows. So really the number one goal of Opal is to make it so that users don't really know they're using Opal. We just want them to have privacy, and we want them to go about their day. Like, it's just way too much effort to like bridge tokens back and forth, like interact with a separate network. So it's just much better if people just get privacy. You don't have to think about it. Like, the best privacy is the privacy you get by default, and that's what Oasis is trying to solve.
Let me ask some questions to Aztec, and I'd like to go back and forth with you on this, Josh, and ask you first. What would you like BNB developers to know now in order to start building on Aztec?
Yeah, I think the best thing to do would be like to check out Noir. And we're seeing an emerging use case that's getting pretty popular. And it's just, since Noir is now general purpose for essentially all EVMs, BNB devs could start building with this now. But we're exploring how to enable private DAO voting, like Nick was saying. There's concerns around how public it is, and like rightfully so. You can actually build designs, you can build apps using Noir that leverage like voting systems that can be privacy preserving. So you don't know who's voting which way, you just know the proper number of votes were cast, and everybody who should have a vote does have a vote, things like that. And like our internal teams are working on these designs now, and we're working with some partners as well. And we will publish them as open source when they're available. But these could be leveraged on BNB as soon as they're published. I mean, they're just compiling verifier contracts to Solidity that can be deployed on BNB, and DAOs leverage them on BNB. So, yeah, I think checking out like noir-lang.org is a great place to start. That's a book about the Noir programming language where you can get started, learn about what the language is today, and we will be posting frequent updates there. So, yeah, you don't need to be building on Ethereum to build with Aztec.
That's beautiful. And I really like the way that you put it. And there's some very key use cases. And I've actually seen the private DAO voting use case be like the number one go-to for now. And so can you give us a little bit of more like of what's though to be expected with building with Noir? What is it that you'd like to tell the developer, what they should be really kind of familiar with before they start working with it? Can you name some things like what is Noir similar to? Is Noir a replica of a smart contract? It's just written in Noir, or is it our job to figure out how to build new Noir contracts? I want to know Noir from your point of view. What is it like, and what do you want builders to know about Noir before they start building with it?
Sure. So Noir has we use a Rust syntax. So the syntax will feel familiar to Rust. The programs will look similar. But it is a domain-specific language, meaning you only write Noir programs in a very specific context for very specific things, and that's generating proofs of computation. So you're not actually writing programs that do things, you're writing proofs, you're creating proofs that verify that computation was done properly, which is kind of like a shift in thinking about how what a program is actually doing. The most comparable thing right now that's the most popular is the CIRCOM language. Noir is different than CIRCOM in the sense it's higher level, so it abstracts away some concepts that are particular to writing zero knowledge proofs. So in CIRCOM, you have to define constraints and set the stuff quite manually in the language itself, which is something that you would not do outside of a proof writing program context. Noir abstracts this away, so you just write familiar syntax of we have for loops, you can create arrays, you can we're adding more features around doing hashes, Keccak hashing is important for Ethereum, as well as verifying Ethereum signatures. That's on the way. These things have historically been very difficult in zero knowledge proof languages just because the computations are intensive. It takes a lot of power to create them, and doing it on consumer hardware is difficult, but we're getting there with our basically cutting edge proving systems that we're building at Tech.
That's
so
beautiful. Okay.
Yeah, it's a DSL. It's very specific to this one context, and just getting familiar and reading examples is the best way to get started.
Beautiful. I love it. And I really think that there's a lot of fun that I think developers can start having now. It's if you're a Rust developer, clearly it's going to feel very familiar. But the way that I have to then kind of figure it out is a little bit different, since it's generating proofs of computation. So if I needed to send a specific input to my program, I would write a Noir program to specifically generate a proof for that specific input from my smart contract and give it back. And then various different aspects of my, say, ZKP is then put into my program or my application. And this is all done on the client side, since it sounds like it's compiled directly with the client. It sounds like me, the person, the user, is generating the proof on my end. I'm just accessing this program on through the DApp interface. Is that sort of correct? Am I wrong in assuming that's kind of how it is?
Yeah, that's generally right. And yeah, these proving programs, like we compile them down to WASM, so they're like really fast in the browser. And yeah, users are putting these inputs in on their side. And then if anything needs to be verified on a contract, like that's defined in the Noir program as just like a public input. And that can be passed along with any like transaction to a smart contract posted to the website or whatever it may be.
Beautiful. That was a great way of explaining it. And so with and Josh, you're doing a great job at explaining these things. So I'd like to ask you really specifically with BNB and then Aztec. Can it hypothetically be compatible with one another? Can you walk us through how Aztec really kind of connects on Ethereum right now, so that way we can give the BNB development community sort of an idea of what that connection sort of looks like right now?
Yeah, so since we're a rollup on Ethereum, we essentially have a rollup processor contract. And like if you want to put assets into the Aztec network, you just call a function on that contract and send along the corresponding ETH or DAI that you want to deposit. That's the simple case. In the future, when we have Aztec 3 and we have light clients on multiple chains, like one of those chains being BNB, we'll just have a smart contract on Binance chain, and there will be functions. There will be a defined function interface. We'll publish it. You'll be able to see it on the Block Explorer, and you'll just call deposits there. So yeah, it's actually pretty simple. It gets complex when you start like having assets in the chain, and then you want to do interactions with L1, and like when we have private and public state, it will be even more complex. But yeah, the interaction with L1 is pretty simple, and like we will always rely on Ethereum as like the official like consensus layer that we're posting data to and verifying the state of the network against, because Ethereum is the most decentralized network. It's like the most secure. So like the contracts and like the state that these contracts from other chains are updating to, like, will still inherit security of the Ethereum network.
Gotcha.
The contract itself on BNB obviously won't, but like the assets that are passed into Aztec through that contract will then inherit Ethereum security.
And so when I'm speaking with these light clients that you're speaking about, let me just go on a slight tangent here. That's where the computation would then be run. So if I'm interacting with the DApp, say on BNB, this light client exists in the future. We're saying that I'm actually speaking to this light client, which is a part of Aztec, and then the data is then being posted to the Ethereum network as a proof that it then happened. So is it that we, as like another chain, BSC chain, is really just getting these, instead of posting it, we're actually just receiving that data on say like our own Block Explorer and saying, hey, this contract did interface with the Aztec Light node, get that data from Ethereum, post it back onto our Explorer. Is that sort of what we're saying here, or is that not exactly it?
To be honest, I'm not totally sure. I would imagine there's a way that like we're posting updates to the Binance contract, BSC contract. I'm not totally sure how it works. Like our engineering team is literally designing this stuff now. So it's a ways out and it's definitely subject to change. But like in theory, this stuff we'll have this like huge network across all smart contract chains, connections to Aztec.
Awesome.
So yeah, TBD on details.
Awesome. Well, yeah, you did a really great job of explaining it in a lot of it. And really quick, what is sort of like your roadmap in your own kind of short letter form? What is it that you'd like to let people know what's coming for Aztec this year?
Yeah, so short term, like we're getting these updates to Noir, so we're updating the proving system so it's faster. We'll be able to efficiently verify Ethereum storage proofs and ECDSA signatures. By the end of the year, we're targeting like DevNets for Aztec 3, the smart contract network. And then 2024 will really be like building out the developer community, launching the network, first versions of the network. And yeah, so like Noir is definitely a great place to start. Aztec 3 or Aztec Connect is live today, and we're just gonna like keep running it as is. We're kind of like shifting our focus to Aztec 3 because we really want to build new network. So yeah, that's the main points.
Awesome. Well, you did an awesome job at explaining it, and of course, you're more than free to see how Oasis is working on the same problem. And I want to curve right over to you, Nick. And now I want to get to know TEE and just understanding how simple it might be for a BNB developer to really kind of interface with this TEE and what it's like actually running private computation on Oasis. So I'd like to know this sapphire thing. You guys got different emerald names and stuff. You got gems and stuff. So I don't know what everything means yet. So I'm going to draw it all out on the screen. And I'd really love to know what the heck is sapphire? What is opal? Just really briefly before I start getting to some of these questions, because I feel like I needed to lead with that first before everything else.
Good question. Okay, so at the very base layer, you have the Oasis network, which is just like the consensus layer. So just like how BNB Chain has like the beacon chain and it has like BSC, which is the execution chain, Oasis network is basically the beacon chain. It just handles all of like the bare metal rollups coming in from the execution chain. So in the past, we had Emerald. It was just normal EVM, and that was like more of a tech demo. And that was it was like closer to BSC than anything else. And now we have Sapphire. Sapphire is a confidential EVM. And what that means is that you have full EVM compatibility, but when you write private in Solidity, the stuff really is private. So on networks like BNB, right, you have the Solidity private variables that you can just access if you have like a full node on you. So you just pull that data out of the full node. And then if you actually have the full node, you can like poke in your head and see what's going on under the hood and take out all of that computation that's going on. So on a confidential EVM like Sapphire, you have private state, meaning that whenever a contract puts a value into state, it's encrypted. When it pulls it back out, it's decrypted, but only inside of this trusted execution environment. So I've used this word a few times, and a trusted execution environment is basically like a server in a locked room where nobody has access. So of course, it's not like that in the real world. It's like this special chip on your CPU that, it's a mode of using the CPU that makes it so that all the stuff going into that memory is secure and encrypted, and the OS can't look inside of the TEE. Only the CPU can see in the TEE, and we then bring that through Oasis Sapphire to the smart contracting world and give you private smart contracts, which are basically like smart contract TEEs. And since the biggest value in like blockchain space is on these public networks, we put the data into Oasis Sapphire using Opal. So Opal is just a way of using Oasis Sapphire as a TEE essentially, to do this private computation using private smart contracts. And it brings a lot of value to developers on other networks like BNB Chain. And it's really, really easy to use. So like devs don't really want to learn. I mean, like devs like learning. That's like why they're devs, right? But they just want to ship product. So if they don't know how to write like Rust. I mean, I'm a Rust developer, but like I don't love it. I mean, I do, but I don't, right? It takes too long to compile. Like I'm on like TypeScript all the way. Anyway,
Yeah.
actually Solidity is a solid language, right? Like it has solid in the name, like it's good. It actually is a very good match for the key value store operations going down on the blockchain, right? So we decided to just take that wholesale, like it's just really good. So developers come over to Oasis Sapphire, they write Solidity. It's EVM compatible, they test it using Hardhat, they simulate it using Hardhat Node, they post it to their Web3 gateway, they interact with it using MetaMask, they use Ethers.js, Web3.js, like they get all of the tooling that they currently use, and they don't have to learn a single thing. All they need to do is write their contracts and then deploy them to Oasis Sapphire, and then have like the bridging part going on. So they need to add a little bit of bridge code. That's maybe like 10, 15 lines, and then split up their app correctly. But I mean, that's like always challenging, right? Like putting the app in the different parts in the right place. Like where does the privacy go? What's the public part? But I mean, worst case, you just put everything in private and on the private part in Oasis Sapphire. But like, let's say all you need, once you split it up, it's just a matter of writing it out in Solidity, testing it, deploying it, and then just having it run on the bridge. And one of the nice parts about the bridge is that like, Oasis privacy layer already supports BNB Chain, already supports Ethereum, already supports Polygon, Avalanche, and all the other fun networks that developers are using. And I mean, if there's anything that we should understand from the real plethora of EVM compatible networks, is that EVM compatibility is king or queen. And that's what we're really going for. You just write your confidential smart contract, you deploy it, and then you get privacy.
That's beautiful. And you're saying like we just add a little bit of the bridging code to go back and forth between BNB and Oasis to get into this TEE layer to have then use a private smart contract. My DApp on the BSC, hypothetically, let me just try to understand if I have this correct. So I put in inputs using Opal, and it goes into the TEE, which is then called Sapphire. That's where our private smart contracts are then privatized. But then I'm still using Solidity, so I can essentially say, hey, smart contract on Binance Smart Chain, can you please run Opal and then run inside of this TEE, post this data to Oasis, and the Sapphire will then relay back using a bridge component? Where is this bridge component exactly?
Yeah, so that's actually a really good summary. And then the bridge component is we have a couple of message passing bridges. It's all the rage these days, right? Like token bridges are so 2022, and now we're on message passing bridges. So you have like the wormhole message passing bridge, Seller IM, multi-chain any call. So right now we are using we actually have a few bridges that we're using for message passing, just because unlike tokens, it doesn't really fracture any liquidity. It's always better to have more routes to your L1, right? So you can choose whichever route you want to use based on the fees, availability, speed, like your particular trust requirements. But the overall idea is that you send your message through one of these message passing bridges, and it automatically hooks up these networks.
Cool. Okay, so choose your bridge, do your app in your own way. Very cool. So when you speak about the confidentiality of the actual smart contract with Sapphire, I know I asked Josh about this before, about what exactly is then private. It seems like I can be very selective with the amount of privacy that I have in Noir, since it seems very customized, and I can essentially make my asset type, the asset amounts, the sending and the receiving address. He's compared it to Monero or even like with Zcash. So can you explain the aspects of what sort of privacy are we then getting with like a typical token? Like let's imagine the Oasis token, let's imagine the BNB token. Can you give us some of the aspects of privacy that is enabled in these smart contracts? What is then the state before and after for a token?
Mm-hmm. So the computation that happens on Oasis Sapphire via Opal is so it's more private the longer you keep the assets there. So everything that you want can be private, like the sender, recipient, the balance. But of course, like if you're going to be sending something over and then sending something back immediately, your anonymity set's pretty small. So the anonymity compounds and the privacy compounds as you leave it on the private side to do things like do private DeFi and stuff. But privacy isn't always, you don't want complete privacy, you don't want complete transparency. So either way is too bad. Like regrettably what happened to Tornado Cash is because the privacy, like the auditability features weren't appropriately used or marketed. So yeah, we definitely don't want to get into that. So it's important to have the DApp developers be able to protect themselves, their users, and their DApp by creating these private smart contracts that have selective privacy. So let me give you a quick example of where this might be used. It's a DAO that does secret voting, right? So for privacy reasons, while the vote's ongoing, you don't want to be leaking the actual votes. You want to keep those votes private. But at the very end, you want to know that all the votes, like you want to be able to see who voted for what and like get some kind of accountability for people and how they vote, right? Like, I mean, in like US Congress, you do want to see how your representatives are voting. So on the private smart contract on Oasis Sapphire, you can set once the voting has ended, then all of the votes become public. And that's approximately 3 lines of Solidity code. You just need to check if voting has ended, just like one require statement, and then it's good to go. But then that kind of thing applies for anything. Like anything you want to be private can be private, and anything you want to be made public can be made public.
So it's private as so long as the contract is compounding. You said compounding privacy almost. I don't want to mistake what you're saying. So can you explain to me what you mean by compounding?
Yeah, so let's take another example of like private salary payments. So like you have a bunch of different companies, they want to send out salary to employees, which is pretty important these days. And like when you have so many Web3 organizations, you don't want to be, people don't really want to be giving out their salary information. You don't really want to be exposing how much like capital you have. So if you were to simply pay people on Oasis Sapphire and then bridge it back over, then you like immediately disclose how much you're getting, right? I mean, the alternative is that you can leave it on Sapphire and then only take out little bits of it when you actually need to use it. And like the longer it stays there, the more privacy you get because you're not just like disclosing the entire value by like moving your entire salary payment over. And then so the compounding part is where you have like these other apps on Sapphire where you have like this ecosystem of private apps on like what you could consider the L1. So Oasis privacy layer is backed by this Oasis Sapphire, which is like its own network, right? But we're not using it like that necessarily. But like you can have DeFi lending protocols where you can like privately make some money on your salary payment so that it's not just sitting there compounding privacy, it's also sitting there compounding assets.
I see. So that makes complete sense. So let me try to put it in a really nice way as well, because I've worked on some of this before with Discrete Labs. Is what we said is it's almost like you are making privacy publicly audible but private by default. So you have a level of privacy when you go in this TEE, but the moment you pull out, it's then made public. And this is very true for a lot of the way that if I'm on a private network, then I bridge it back over to a public network that is then posted to that particular network, and everyone can see it, but maybe no one actually knows the receiving address. Maybe it might be a different address and they can't link it to my identity. So there is some caveats that I think that you personally are working in and around of, except that you're at least making it audible. So there's a level of audibility. And that's, I think, strongly important. So the flexibility, let me move into this, is how much flexibility does a developer have when choosing what is then hidden on the TEE, on Sapphire? What kind of flexibility do they have? And like what remains transparent versus what remains, say, like anonymous? Like the difference between pseudo anonymity, and public transparency. What is the flexibility that a dev has?
I mean, you could almost say too much because like you can write anything you want and there's security properties to everything, right? So when a token moves, you can see that the ID is moving. I mean, alternatively, you can apply some really expensive security techniques like oblivious RAM to hide that even the token is being moved. So like you don't even need to know that a contract is being accessed. Like the contract might be pulled out of a random location in storage every time. So you can get as deep as you want to create as much privacy from like the world, even the node operators, like everyone. or you can have no privacy at all, and then you can just go on your way. Like, it depends on your threat model, right? Like, if you're going to get, like, I mean, to quote from this one very popular humorist on paper, like, if you're going to get Mossaded, like, you're going to get Mossaded, right? Maybe that's not your threat model. But, like, if you're trying to protect something, like, if you're a reporter and maybe against some other lesser adversary that's not going to, like, beat you with a wrench or something, then, like, you can program all of that in. It's just really to your heart's content. I mean, we have, like, the simulator and hard hat node that everyone uses, and it's exactly the same as Solidity. It's like EVM. It's like entirely EVM. We use an EVM implementation under the hood. So you get all the same speed. It's as though you're just programming on Ethereum or BSC. It's totally the same. So when you actually interact with a network, the block time is actually a little bit shorter. It's only 6 seconds. So you might see a little bit of speed there if you're just interacting with the Oasis Sapphire side, which you do sometimes to preserve privacy. And then when you want to actually interact with the L1, you have to wait for the bridge to do its thing, which might take a little while, but you can always speed it up by paying some more money. But if you've ever used like a token bridge on like one of these instant finality networks, it's pretty fast. But it's longer than a block time, that's for sure.
Nice.
But then as you're executing, it's the same.
How does this relate to your latest product? The Oasis privacy layer. Like, where does this Oasis privacy layer then kind of come in? Why was this built specifically? What was Oasis like before and then after the Oasis privacy layer? What were you trying to solve?
Oh, such a good question. All right, so before we were going to launch a WASM smart contract environment that is like so advanced and so cool that everyone's just going to like definitely use it. And because it's also private, like you're just going to move all your dApps over. And of course, that was a complete mistake. I mean, like no one wants to change their stuff. And like we learned from that. We learned from it really well. So now we're just going Ethereum all the way. And yeah, here we are with the Oasis privacy layer saying like, keep your dApps on Ethereum, keep your user on Ethereum, your assets, like everything on your layer one, it's great there. Just leave it, add privacy just as you need it. Like if you don't need privacy, don't add it, but like it's your privacy, like use it when you need it.
You specified Ethereum, but can you walk me through how a BNB developer would then use the Oasis privacy layer? Like how simple and complex do you believe is going to be the integration for a BNB developer?
It's actually the same, just as easy for an Ethereum developer as a BNB developer, like probably even easier because like BNB is just more scalable and very accessible. So I think like since you're already in the BNB ecosystem, it's like just as easy. You just crack open your developer environment, you import the Sapphire hard hat integration, assuming you're using a hard hat, and then you just get deving, and then you hit the hard hat deploy button, and it's deployed.
Beautiful. You guys have a very unique value proposition that I think really relates to the BNB's mission, because we recently released Project Greenfield, which is a decentralized storage network. And I know that Oasis had some interesting kind of prospects with it. And so can you explain to me what Oasis has to do with cloud storage provision? Like what do you guys specifically do with cloud?
Mm-hmm. I am so happy that you asked about Greenfield. So I read the Greenfield announcement the day it came out, and I'm really excited by it. Like I think it's a game changer because it just puts all of these useful features all in one place, and it really has a very compelling privacy roadmap. So it's still up to the team to figure out exactly how to do that based on the white paper, but like it's really great that someone's actually thinking about it. And I think that Oasis and Opal really have a good fit there because what you want, right, is to be able to add permissions, like very complicated permissions, potentially based on some data that over the data that you have based on like some attributes of you or the context. And like you can program all this up using like zero knowledge and other stuff, but like it's very simple to create a Solidity smart contract that says, hey, do you have access to this data? And if you pass all the checks, then it like dumps out the encryption key, logs it with immutability on chain, and then it allows you to decrypt the data and actually view it within either your own computer or a trusted execution environment. And that's all good. And the benefit of Opal there is that like the user doesn't even need to know Opal exists. So if you wanted to add like this very configurable privacy to Greenfield over the data, then you could just do that and users wouldn't even know it's happening. They would just know that their data is resting soundly encrypted where nobody can see it.
That's awesome way of looking at it. So if I put my data in store in a bucket, then I can essentially store that in a trusted execution. So do you believe that this can then be leveraged across other decentralized storage networks such as like IPFS? Do you think that Oasis is not just for Greenfield, it's like meant for other like Arweave and all these other ones as well?
You could. But I mean, Greenfield has some very nice like properties, right? It has the great integration, great security roadmap. Like it's just more complete. But like, yes, you can use key management for any storage network. But I'm like particularly excited about Greenfield. Like I'm actually so excited that I'm actually putting it on the roadmap to create like a Greenfield integration so people can start using it. Like it's nice to have.
Now, Nick, is there any final words that you would like to tell anybody about Oasis? What is your roadmap? What are your plans this year? What are you excited about, and what are you doing specifically?
Yeah. So, well, for anyone who's listening and just like interested in Oasis, you can please feel free to like reach out directly. Like my email is like nhynes@oasislabs.com. So like I love developers. I'm a developer myself, of course, and I'm just going to keep on developing. And I just want other people to enjoy privacy and be able to just add it to their apps, then give it to their users, because it feels good when it feels good when you're doing the right thing. So that's what makes me excited. That's what I'm going to continue working on, just like making the Oasis privacy layer better, more convenient for developers, more transparent to users, and then adding more scalability, privacy for like when those really obscure cases when like you need privacy from like state level actors and that kind of thing. Like we're shooting for the moon on this one.
Nice.
Wow, I was trying to keep up with you guys talking about the privacy. And yeah, I think you guys are on the right track of just getting in on the enterprise side more than on the user retail side. I think what's kind of interesting though is like the selling of strategies and the deployment of services anonymously. So like you're saying if you want to like for your decentralized storage or different kinds of computation, I think those use cases are really interesting.
Yeah, we do actually go for enterprise. Like enterprise is where the security is, right? Like enterprise loses, like you're trying to increase revenue, reduce costs, and like it really hits enterprise the most when you have like a breach, and it increases user trust, increases the revenue. So like it's just good for everyone, especially when you target it at the people who are going to be, the people where the data is being centralized. And all these enterprise that we have are building using the Oasis privacy tools. Like some are using the data, our data infrastructure, some are using our differential privacy infrastructure, and then others are like more on the cutting edge of like AI privacy. So we're working with all of them to just as a complete privacy picture for the entire platform.
That's super cool, man. Well, you, Josh, Nick, you guys were amazing. Thank you so much for staying and explaining what you guys do. And I think the BNB community is going to be really happy to start exploring their options now with privacy. And since they can see that both are going to be able to be compatible with BSC, there's a huge chance that you're going to see a different influx happening soon. So I love your guys' direction. I love the way that you really are kind of tackling these key issues, and you've explained so many different use cases. So thank you so much for your time, and we'll end it here. Thank you so much.
Thanks, guys.